Good morning, class. Good morning once more. Welcome to today's lesson. Today we are going to cover direct memory access. We are going to see that sometimes it's not always good for the microprocessor to be engaged on exchanging data between, that is, the input-output devices and the memory. Sometimes this task is very heavy when it comes to microprocessor, and that's why we need a special way or a special device to handle this task. So that special device is direct memory access controller, and this is what we are going to cover in this topic of direct memory access. So please join me as we continue with this part. Thank you. So in this topic of direct memory access, you are supposed to explain the need for direct memory access, describe the DMA operation, and describe the operation of Dma controller. So we are going to cover need for direct memory access and DMA operation in this first lesson. The second lesson, when we meet physically, this week we are going to have a physical class. In that physical class, I'm going to cover the DMA controller. So the operation and the need for DMA is going to be covered in this topic. So why do we need a DMA controller? For us to understand that part, we have to visualize how data will always occur, how we normally exchange data if we don't have a direct memory access. So it means that anytime we want to send data from the input-output devices, let's say a sensor which is connected to an analog digital converter, or a USB flash disk which is connected to a USB port. So anytime you want to exchange data, you have to exchange that data between the microprocessor and the memory. That is, the data must pass through the microprocessor for it to go to the memory. Now the problem with that is that the microprocessor is going to move data bit by bit, which is very slow. So if you are moving a very huge amount of data, it's going to take a long time for that exchange to occur. Another thing, when we are exchanging data with the microprocessor being engaged, remember that other processes which the microprocessor is handling is going to be slowed down. So the key idea here, you have to understand that DMA allows data to move between memory and peripheral devices without burdening the CPU. So without the DMA, CPU must handle every single data transfer. So this wastes CPU time on repetitive low-level tasks. Example, when we are copying a large block of data from an analog digital converter to a RAM, CPU is stuck doing postman work instead of thinking work. So what they are trying to say that we better engage the microprocessor in thinking task rather than engaging the microprocessor in transferring task, which is going to be a very small tedious task for the microprocessor. So with DMA now, you see here we are going to have a dedicated now controller, another IC, which is going to handle the task of transferring data between the input-output devices and the memory. So you see here the microprocessor is not going to be engaged to handling other things. So it's going to be idle in the background, not even idle. Maybe it's going to handle other activity at that moment. But remember that it's not that the microprocessor is going not to be engaged fully. Of course, remember the microprocessor is going to initialize the first phase, whereby it's going to send some control signal to the DMA for the process now to start, and even the process to end. We are going to see that. So a dedicated hardware unit, that is DMA controller, moves data directly between memory and input-output devices. CPU is free to run other instructions in parallel. This improves speed, efficiency, and real-time performance. So you have to understand that one. So a good analogy is whereby think that we have a chef. So think of the CPU as a chef. Without DMA, the chef has to fetch every ingredient from the store personally. With the DMA, there's a kitchen assistant who brings the ingredients while the chef keeps cooking. So the chef is going to focus on cooking while the kitchen assistant is going to bring the ingredients. So you see, the kitchen assistant is going to focus on the task, which is actually might be small but repetitive, which is bringing the ingredients, and the chef is going to focus with the main task, which is thinking, which require thinking, which is what? Cooking. So that's a good analogy. So we have to understand the analogy of how the operation of the DMA, how the DMA works. So the DMA has 3 steps. So the first phase is the setup phase, which is done by the CPU. So here the CPU is going to send some control signal to the DMA controller. These control signals are going to tell the DMA controller the source address where data comes from. Yeah, it might be coming from the flash disk or the sensor, which is connected to the analog digital converter, a destination address where to store that data. That one is going to be inside the memory. So we are going to share the memory address to the DMA controller. Another thing is the number of bytes or the words to be transferred, and the transfer mode, which we are going to look in our second session. So we are going to look that we have fast, cycle steering, transparent, among others. So after the first phase, whereby we see that the microprocessor is going to initialize the process of transferring data through the direct memory access by sharing some control signal to the DMA controller. The second phase is whereby now we have the transfer phase. So this is done by the DMA controller. So in this phase, the data is going to be transferred now between the source, which can be either the sensor or the flash disk, which is connected to our microcomputer environment, to the memory. So move data directly between source and destination. CPU is either paused briefly or runs in parallel depending on the mode. And then the last phase of operation, this is the completion phase. Now the completion phase is whereby after the transfer of data has taken place, the DMA controller is going to return the control functions or the transfer functions back to the microprocessor. So the completion phase, the DMA signals the CPU via an interrupt that the transfer is done. CPU continues or switches to the next task. So we are going to see that this actually is the completion phase, where now the microprocessor is going to take back the control of the buses. Remember, when we are exchanging data, the buses are going to be taken by the DMA controller. So after the DMA controller has finished exchanging data between the input-output devices and the memory, is going to return back the control of the bus to the microprocessor. So we are going to look at this in details when we look at the modes of data transfer which occur between the input-output devices and the memory. That one is going to happen in our physical class. Also, we are going to have another session whereby we are going to look at the specific IC which carries the operation of data exchange between the input-output devices and the memory. Thank you so much. This was a short session. It's part of the lesson which we are going to it's part of the lessons which we are going to have for us to cover this topic of direct memory access. So in case of anything, in the case of question, in case of any difficulty, please reach out to me. You know my number, reach out to me. In case of next question, you found out about a question from next paper, please, you can forward to me so that we solve together. Enjoy your day and enjoy your day, and remember, we are going to have a physical class in the course of the week, so please avail yourself when I call you. Thank you so much.